be introducing David Ansermino. He's the VP of Engineering at Chainbridge Systems. And also I'll be introducing James Kreswich, our very own James Kreswich, who always has a bridge to sell you. So folks, you want to give it an introduction, a brief introduction about you both and kick it off?
Yeah, I mean, I can maybe just jump straight into things. So my name is David Ansermino, and yeah, I'm VP of Engineering at Chainbridge Systems. We are a blockchain research and development firm founded in Toronto. And today I'm here to really give an overview of our project Chainbridge and explain how the Celo integration that we've been working on kind of works. So before diving in too deep, I think it's important to give some context for how we got here and what our motives are. In the early days of ChainSafe, we worked largely in the Ethereum space, and we saw a lot of people who were moving to sidechains. And this was really a kind of a short-term solution to the scalability issue, but it really started to demonstrate a growing need for cross-chain communication. And although the scaling solutions have come a long way, the segregation of ecosystems continues to be an issue. And we continue to see this to be a pretty exciting problem, because we believe if we can solve it, it could unlock a huge amount of potential within some of the existing technology. So Chainbridge is really a developer toolkit to build bridges between blockchains. Some of the key properties of Chainbridge is that it's extendable. So we're able to develop integrations for many different chains. These integrations can be simple and follow a basic protocol, or more extensive and include some additional features. It's also modular. So for the chains that are supported, they can be combined in different ways to construct different bridges between each other. It's also very customizable. The data that is passed across one of these bridges can be entirely arbitrary, and the on-chain components are not limited to specific interactions such as token transfers. So for example, you could use the bridge for transferring an ERC20 token from one chain to another, or you could use it perhaps to initiate a vote in a DAO from one chain while the DAO lives on another. Here we have a high-level diagram of the Chainbridge architecture. As you can see, there's 3 chains, A, B, and C, and an instance of a bridge relayer in the middle. The relayer consists of modules which are responsible for reading from and submitting transactions to the respective chains. And then these modules pass messages between each other to communicate transfers. In a typical bridge construction, you would have multiple of these relayer instances, all participating in each of the bridge transfers. With the Celo integration we've been working on, we had the opportunity to explore reducing some of the trust assumptions in the relayers. And this was done by combining 2 proof mechanisms. So the first one being Merkel inclusion proofs, and the second being BLS aggregate signature verification. So just to give a bit of information on how these actually work, we can use a Merkel proof to effectively show that a transaction is included in a block. So each block that's produced contains the root hash of what's known as the transaction trie, which is a Merkel trie constructed for each block consisting of all the transactions that are included in it. The proofs for these are pretty easy to verify and have a very low space complexity. For example, if we wanted to prove that the transaction in green was included in this block, we would just need to show that these other nodes in red can be used to reconstruct the root hash. So it really just involves several hashes to recalculate that. And if we produce the same root, then we've successfully shown that it was included in that block. Moving on to the BLS aggregate signature verification. Within a Celo network, the elected validators will individually sign a new block, and these signatures are combined to produce an aggregate signature, which is associated with that block. Similarly, we can take all the public keys of these validators and combine them to produce an aggregate public key. So in a single verification step, we can then verify that the elected validators did produce a specific block. So for a bridge, these proof mechanisms provide limited utility individually, but by combining them, we can show that a certain transaction was included in a valid block. And this really removes some of the trust assumptions that we're placing on the relayers who are responsible for transmitting the transfers from one chain to another. Looking ahead for Chainbridge, our focus will be largely on improving the developer experience. Right now, we're working on refactoring our overall architecture to reduce friction when it comes to building custom bridges. We definitely want to create more documentation, tutorials, etc., to really lower that barrier of entry. We're also looking at adding support for some additional chains. In addition to Celo, we also have support for EVM-based chains and substrate-based chains. And we're really excited to explore some of the potential of some L2 solutions that are coming out these days and to see what potential features that could unlock for us. We're also very interested in looking at other trust models, similar to what we've done here with the Celo integration. We would definitely love to see, a entirely decentralized bridge in the future, and that's really what we're kind of working towards as our ultimate goal. So that's all I have. Thanks so much for listening. Definitely stay tuned for the official release of our Celo integration. If you're interested in any of this or just want to chat, feel free to reach out to me through any of the means that are listed here. Like everyone in the space, we are hiring, so please check out chainsafe.io/careers if this stuff gets you excited.
Next up is James Kreswich, who's going to be going over interoperability and chain and bridges for happening at Celo. James, do you want to take it away?
Sure. I am trying to share my screen, and we're going to see if we actually can make it work. I was just doing this yesterday. I don't know why it's not working now.
Well, finger crossed that it works.
Well, while we're doing that, I can go ahead and give a quick introduction of myself. My name is James Kreswich. I've been working in crypto for 6 or 7 years now. I got started in this way back in 2013, 2014, before Ethereum was a thing, before there was, more than one chain that people really cared about. My interest in crypto has really developed a lot over the years. I started off working just on Bitcoin things, and as the space grew, my interest in the space grew with it. And so a few years back, I decided to, really specialize in cross-chain applications, and started a company with a few friends back in 2018 called Summa. So Summa worked specifically on cross-chain trades, cross-chain contracts, cross-chain bridges, and obviously in 2018 we're very early to this space. We worked on Bitcoin, Ethereum, and anything else that was available at the time. This is telling me I need to quit and reopen Zoom to make it work. I'm so sorry. I'm going to do that in just a minute once I get through the introduction. The main, learning from Summa is that we were very early to interoperability, and there was a lot of work to do in this space. And so last year, last August, the Summa team decided it was time to stop working on random little projects and buckle down to really get something done and get back to working for users rather than on kind of technical showpieces. And so we joined C-Labs last year to really focus on building out the bridges team at C-Labs, and working with Chorus One and ChainSafe and other people to kind of kickstart this cross-chain ecosystem for Celo. I'm going to go ahead and drop out. I would recommend you start doing Q&A for David, and that'll give me some time to fix my setup. I'm so sorry about this.
No worries, no worries. All right, we'll do a little Q&A with David. So David, I'm I know Greg, who used to be like VP of engineering, and now you're like the VP of engineering. So tell me, what's it like being ChainSafe and working on all this cutting edge project that ChainSafe is doing? Because in my opinion, ChainSafe is one of the leading engineering firms in crypto, working on all these different projects and stuff. So I'm kind of curious about your experience.
Yeah, I mean, thanks for those kind words. Definitely, I feel really fortunate to be working in this space. We were very lucky with our timing and, so many things that really just aligned for us. From the early days, we've always tried to be very chain agnostic, and that's really given us a possibility to explore so much technology and really prevent us from doubling down on something that would maybe limit our ability to continue growing. And so, I mean, today there is, more excitement than ever in this space and more projects than ever popping up. And so, we're really trying to figure out what's going to have the biggest impact from a technological standpoint, and really try to continue our focus on the technology as we continue to grow and start to participate in so many of these awesome ecosystems.
Oh, amazing. I'm gonna hand it over back to James to kick off the optics presentation.
Thanks. So it turns out when you update OS X, it resets all of your preferences here. So that's what was going on, is a recent update. So getting back into it, I already gave a brief introduction of myself. I've been leading the Bridges team here at C Labs for quite a while now. And we've been working on a newer model for cross-chain communication. David gave a great overview of kind of the problem space, is that everything is really siloed. Every chain exists in a completely separate ecosystem. And it's very difficult to get things moving between chains. It's really kind of unpleasant working cross-chain. You have to go out and learn some existing ecosystem. You have to learn the in-depth consensus details of the remote chain. For Celo, you have to know about BLS signature aggregation and the validators and how those are rotated. For Ethereum, you need to learn about ETH hash and get into the internals of the proof of work. Each bridge is bespoke. And for these relays, where we're actually moving the signatures over or moving the headers over, and then we're doing the Merkel trie verification, they're incredibly costly. A few years back, I built a Bitcoin relay, which currently runs TBTC. And the Bitcoin relay is the cheapest possible relay you can build. It takes one Bitcoin header every 10 minutes, and it currently costs something like 10 ETH per week to run. So the Keep team is running that and spending a really unpleasant amount of money just to keep Bitcoin up to date. When it comes to more complex systems like proof of stake, like ETH hash, like all these other chains out there, it looks like relays are not going to be a long-term viable option without a lot of subsidization from the chain itself. And so as more and more chains come online and you need more and more of these relays, you see a huge fragmentation in bridging technology and ecosystem. So right now, almost all bridges out there deployed are completely custodial and trusted. The major exceptions are TBTC and the Near Rainbow Bridge. And we're working with Chainbridge and Chorus One to deploy non-custodial bridges to Ethereum and the Cosmos ecosystem, but it takes a long time. And so we have come up with a mechanism that we think kind of cracks this open and makes it a lot easier to build one bridge that works to go to any chain and to create a cohesive, cheap ecosystem for cross-chain messaging. So the goal is to really just build bridges between every chain. This isn't a Celo to Ethereum specific mechanism. We're trying to build something that works the same on Celo as it does on Ethereum and Near and Solana and Polkadot and Cosmos. And to create a bridge mechanism that just works everywhere without all the bespoke header relay and bespoke transaction try and bespoke event processing that you need today. So the key features that we have come up with and we've been able to build into this are a one-to-many relationship. So unlike a traditional bridge, which goes between two specific chains, Optics works for sending message from one chain to any other, and it uses the same mechanism regardless of the destination chain. Because we're not doing header verification and we're not checking proof of work or validator signatures, we can shave off the majority of the costs of the system. We don't need to spend that 10 ETH per week updating headers. So we can, we think, cut this down to 10% of the cost. We call it trustless, which is, fits better on a slide, but the more accurate term is probably trust minimized. We've chosen a non-custodial security model with a minimum amount of trust in off-chain actors. And we've optimized for ease of integration. So a developer should be able to kick up a new Zap, a cross-chain app in just a few hours, as opposed to having to build out a custom transaction tree processor to get transaction receipts from Ethereum. Generally, the way this works is that there is a home chain for the communication channel that's committing messages, and a bunch of replicas that replicate the commitment. So if the home commits to a series of 20 messages, the replica should be able to get the commitment and unpack each of those 20 messages. So we're reproducing a data structure from one chain to another. And the way we're doing that is using a notary system. So we create this updater, which is an off-chain actor that attests to the message commitment. It is possible for the updater to attest to fraudulent commitments. And this is a big departure from the relayed security model. Optics permits fraud. However, we bond the updater and we ensure that frauds are publicly verifiable. So if the updater ever commits fraud, we know that we can slash them and revoke their bond. The other defense against fraud is that each replica has a time delay. It accepts the commitment only after a certain number of hours. And that gives everybody who is using that replica a chance to detect fraud, which will always be public, and to respond before the fraud can affect them in any way. So assuming that people are generally online and available, the updater will not commit fraud because there will be a guarantee of loss and an extremely uncertain gain. So the timeline for Optics is we've basically, these are internal milestones, so please forgive them for being a little opaque. We're almost complete with implementation and testing. We have the on-chain contracts, we have the off-chain agents. Everything seems to be working okay. We're missing a few features, but we're going to be launching on testnets very shortly, within the next month. And we hope to be running between Ethereum's Ropsten testnet and Alpha Horus, in a few weeks, and opening it up for developers. We expect mainnet a couple months after that. And in the future, we figure out, how does Optics communicate with Celo governance or its own governance system? So kind of the conclusion here is that we're trying to build out an ecosystem with one-to-many relationships where every chain can connect to every other chain, rather than having a complex routed solution. And we're trying to do this cheaper than any other bridge that's been deployed before. Thanks.
Awesome. Well, this has been really exciting. I've been waiting for a while to hear about optics like publicly and stuff. I'm so excited that we can actually unveil it at Kuneco and stuff. So yeah, I think we have a few more minutes. Potentially we can go to like a mini panel on interoperability and bridges. What do you think?
Yeah, I was planning on just hanging out with David and talking shop for a minute.
Yeah, I mean, I think this is a great platform for that, right?
One of the things that I'm excited about is how we integrate some of the optics stuff with Chainbridge in the long run. Chainbridge is a much more mature platform for running these off-chain agents to maintain this type of infrastructure.
Yeah. David, what do you think? Is there any possibility for integration down the line, Chainbridge and optics?
Yeah, absolutely. I mean, I think that there's definitely huge potential for integration there. Certainly one of the very interesting kind of components of all this, which we really want to explore more, is kind of creating a market for these participants, right? Like having individuals who can actually run the software and, maybe they're facilitating multiple bridges, maybe it's just one in particular, but really trying to figure out the incentives and create opportunities for people to participate in that way, I think is going to be really cool to see.
Yeah. Because bridges are so immature, we haven't seen like a lot of standardization around what the roles are and how people are incentivized to run these things. Everybody is mostly just doing like a centralized, trusted service where, Binance runs the Binance bridge. I am really interested in how we like take this monolithic idea of a bridge and break it down into a bunch of discrete actors.
Yeah. Sorry, go ahead, yes. Yeah, I mean, it's certainly going to be pretty fascinating to see. And I think we're already starting to see a bit of emergence with it, certainly looking at stuff like even Chainlink and Oracle, stuff like that. There's already starting to be a realization for the need of these participants and these kind of like discrete roles within these systems.
Yeah, definitely. I think it's interesting to bring up oracles because the trusted bridges are essentially just an oracle-driven bridge, right? If you wanna think about it this way, another way to look at optics is that it's an accountability system for oracles for publicly verifiable information. So when there is an objective correct answer, you can hold the oracle accountable somewhere.
Another thing I wanted to ask, I think Chainbridge is already operational with one network. There's a bridge between Ethereum and Ethereum Classic. Forgive me if I'm wrong, David. Is that right?
Yeah, we do have that. There's also an upcoming deployment on Moonbeam between Ethereum and Moonbeam. And there's also the Avalanche deployment, which has been running for, I think, 2 or 3 months now between Avalanche and Ethereum.
Awesome. So I'm kind of curious if there's going to be a Celo Ethereum one with Chainbridge, or is it going to be an optics kind of thing? What do you all think?
Well, I don't see it as an either or kind of thing. I mentioned this in the presentation. Optics has a weaker security model than a relay. So if you're going to be running very high value messages, you almost certainly want that Chainbridge relay with validating the signatures from Celo. So I don't see it as an either or thing. I think these are likely to exist in parallel a bunch of places.
Yeah, definitely. I think it's really going to come down also to, particular projects that are looking to leverage these technologies. A lot of them have kind of unique needs and are going to kind of push the bounds of this technology. So we're certainly going to see a lot of people kind of jumping in and trying to make use of this stuff, I think, ahead of just like, a big collaborative effort, which we definitely want to move towards in the future.
Mm-hmm. definitely.
So another question I had, what, like, for both of you, if you had a magic wand, what would be one network that you'd want to bridge that you haven't bridged before, but you're like, oh, you want to like test out the tech on that network and want to see if there's a bridge possible?
It's a good question. You know, I am a huge fan of Bitcoin and still think there are ways to do the Bitcoin bridges better than we're currently doing them. So, you know, I'm always got this going on in the back of my mind is how can we improve Bitcoin interoperability?
Yeah, I think for myself, one of the really interesting cases is Filecoin. And not so much for the asset itself, but rather to try to start to explore what, you know, Web3 applications could look like when we have, you know, this availability of storage and start to add these other components and really build this, you know, quote unquote supercomputer of the world.
Yeah, yeah, I've been exploring Filecoin like from a miner angle, and it seems like, you know, it's so costly just to get all that storage. James, just to go back to what you were saying about Bitcoin and stuff, I'm kind of curious. Would, like, in a perfect world where you can do Bitcoin bridging, me, a holder of Bitcoin, I can deposit it securely, knowing that nothing would happen to it, and then, you know, on the other side, let's say Ethereum, I can get the representation of it without any third party trying to, you know, interfere and stuff. Is there any drawback in existing system that you see? I guess.
Well, you know, you can use TBTC today to do that. It works. It's been running out in the wild for quite a while now. The downside of TBTC is that it's very expensive to use.
Mm-hmm.
There's high capital requirements. You have to run this relay that's extremely expensive to operate. I think that we ought to be able to do that cheaper, and that we ought to be able to do it with a better, you know, experience for users who have to pay for this thing.
Gotcha. So gas costs are the biggest drawback and stuff. Yeah.
And, you know, that can be patch fixed by moving this to some layer 2 or something. But it's hard to see, you know, the reason I've had it kicking around the back of my head is because it's hard to see a permanent solution.
Yeah. Because essentially Bitcoin, even though like it's one of my biggest thing in my portfolio, it's essentially a pet rock. But like having it represented in a trustless way and having, like, you know, using that kind of capital on other network would be so valuable. But, you know, for me, it's all about trust. Can we do it trustlessly and in affordable way and stuff? So I think that's super valuable. All right, I think we're at time. So I want to thank both James and David for this insightful discussion on interoperability and bridges. Chainbridge and optics are really interesting tech that I can't wait to mess around with later and stuff.